Hi, it's Mr. C and welcome to Level 6 Math. We're going to start with Lesson 1. Here in Lesson 1, we're going to look at adding whole numbers and money, subtracting whole numbers and money, and fact families. Now, in most lessons, we're only doing one concept, but here at the beginning, we're doing a lot of review. We're going to do some vocabulary and talk about some really basic things. Bear with me through this video because this is a great review for some things that you might have forgotten over the summer or over the year. So we're going to go through finding the sum of two or more whole numbers using the commutative and identity properties of addition, the difference between whole numbers, and using addition to check, and then arranging three numbers in a fact family. So we've got a lot to go through today. Let's start with vocabulary. And I'll be honest, some of this vocabulary only matters in school. In the real world, we don't talk about addends and subtrahends very often. But we do talk about the difference, we do talk about sums, and depending on your occupation, this is good vocabulary to know. If you're going to be an accountant, yeah, you need to know what an addend and a subtrahend is. But in most other professions, not so much. Whatever the case, it is important for level 6 math to know because this is the kind of academic language that we're using in the classroom. So let's start with addends. Addends are any of the numbers that can be added together. So here in this example, we've got 8 plus 3 equals 11. 11 is not an addend here because it's not one of the numbers being added together. But 8 and 3 are. So we've got 8 plus 3 is 11. Addend, addend. And then when you put them together, that's the sum. So when you put two numbers together, 8 plus 3 equals 11. 11 is the sum. It's the two numbers that are put together. Now in subtraction, we deal with differences. So the result of subtracting one from another is a difference. So we have a minuend and a subtrahend. The subtrahend is what you subtract. So 8 minus 3 equals the difference, 5. So that's just a little bit of vocab. We've got a few more things here. Commutative law is the law that says you can swap numbers around. Now we do this in addition and multiplication, and that's it. We can't use commutative law in subtraction, and we can't use it in division. It just means that you can move it around and you still get the same answer. So for example, 3 plus 6 equals 9. But 6 plus 3 also equals 9. So you can switch the order and it doesn't matter. In multiplication, 2 times 4 is 8, but 4 times 2 is also 8. So that's using the commutative law. Do you need to remember this and pronounce it right? Because I'm probably not so much. It's just good to be aware of it, that in multiplication and addition, you can rearrange the order. Okay? Inverse operation, that's the operation that says you can reverse the effect of another operation. So for example, addition and subtraction are inverse operations, and multiplication and division are inverse operations. And we're going to show you an example of that in a minute here. So to combine two or more numbers, we add, this is just review, and that gives us addends, is what we add. And remember, the addends add up to a sum, so that's the total. The commutative property is the property of addition. I said that wrong. The property of addition is called commutative property of addition. That simply means it doesn't matter what order you go in. And then we've got a commutative property of multiplication as well. So let's start with addition. Add 345 plus 67. Now you can add in a lot of different ways, but typically we want to line up the numbers. So we're going to start with 345, and we're going to line up with 67. Now we're lining it up here on the right. So this is where we line it up from. So we want the 67 to be under the 47, not 347 plus 67 like that. That's the wrong lineup. It has to be lined up to the right, okay? So don't do that. 7 plus 7 is 14. So we put our 4 and carry the 1. We've done this before. Now we've got 6 plus 4 is 10, plus 1 is 11, so we put the 1, carry the 1, and then we've got 3 plus 1 is 4, 414. Okay? So, when we add whole numbers, we write the numbers so that the place values are aligned. 345 plus 67, remember those are both addends, and the result is a sum. 412, is that what I got? I might have messed up on that one, hopefully not. All right, changing the order doesn't matter. So if we switch the 347 with the 67, here, let me just show you. Put 67 on top, 345 on the bottom. 7 plus 5 still equals 12, so we put a 2, carry the 1. 6 plus 4 is 10, plus 1 is still 11. 1 and carry the 1. So we're still going to get the same answer. It doesn't matter which number is first. Typically, we put the bigger number on top, but that's tradition more than anything. You don't need to do that. Okay? Now money. Money's a little bit different than just normal numbers. We still want to align to the right, but see $5 here? It doesn't have a decimal point. But technically, it would be 5.00 because every dollar has some cent value. So if you want to line them up, you need to make sure that they have the same number of decimals, okay? So here, we're gonna put $1.25, $12.50, $5. We're gonna line it up, see how the decimals are aligned, and then we can add the 5 to the bottom. 5 plus 2 is 7, and then 1, 2, and 5 is 8, and then we've got a 1, 1875. So just keep them aligned. Okay, now, if one of two addends is 0, this is called the identity property of addition. It simply means the sum of the addend is the same as the non-zero addend. So here the non-zero addend is 5 plus 0. The answer is going to be whatever the non-zero addend is, which is 5. So 5 plus 0 equals 5. If this was 7,000 plus 0, it'd still be 7,000. You just don't add anything with the 0. When we subtract one number from another, the difference, we find the difference between the two numbers. In subtraction, the subtrahend is taken from the minuend. So 5 is a minuend, the subtrahend is the 3, and the sum, or the difference, sorry, sum is addition, difference is subtraction, the difference is 2. Do you need to remember subtrahend and minuend? No, but if you do remember it, you'll seem really smart and impressive to your teacher. So minuend is the number you're subtracting from. The number that's being subtracted is the subtrahend. All right? So let's go ahead and do this. Again, we want to line it up. 345 minus 67, minuend, subtrahend, difference. So 7 can't come from 5, so we're going to add 10 and cross that out and make it a 3. So 15 minus 7 is 8. Now, you can't subtract 6 from 3 because it's a bigger number, so again, we're going to add 10 and make that a 2. 13 minus 6 is 7. And then 2 minus, there's nothing there, so we would just drop the 2 and get a difference of 278, okay? And I'm going to show you in a second here how to check your work when you do differences. So we're just showing the same thing here. Subtract the bottom number from the top number, and we get the difference of 278. Now Jim spent $1.25 for a hamburger. Pretty good deal. It must be on the value menu. He paid for it with a $5 bill. Find how much change he should get back. That's going to be the difference. So we're going to have a minuend, a subtrahend, and a difference on this one. The minuend will be the original amount. That's what he paid. So we're going to subtract. The subtrahend is what we subtract, $1.25. And then the difference is what he will get for change. Now we can put our dollar signs on here so we don't forget. And then we just subtract 5 from 0. We're going to have to change that to a, sorry, I don't have to cross that one out. I'm adding a 1 and making that a 10. 10 subtract 5 is 5. Because I added that, I have to change that to a 9. 9 subtract 2 is 7. And then 5 subtract 1 is 3. So our difference is 375. Minuend, subtrahend, difference. All right, we're just checking our work here because the PowerPoint tells me to do that. All right, now we can check, this is the cool thing I was telling you about earlier. We can check our answer for a subtraction problem by doing an inverse operation. So if we subtract down, that's finding our difference. If we add up, so if we take the difference and add the subtrahend, that will give us the minuend. And so we can check our work that way. We just need to add the two bottom numbers. And here we can do 5 plus 5 is 10, carry the 1. 7 plus 1 is 8, plus 2 is 10, carry the 1. 3 plus 1 is 4 plus 1 is 5. So it checks out. I love math because you can be sure of your answer. It's always going to check out. All right, so addition and subtraction are inverse operations. That's what I just did. So, for example, 4 plus 5 equals 9, but 9 minus 5 equals 4. And we're going to talk about this more later in the year. But when you have two things on one side of an equation and we're solving for a number, what you can do is get rid of one of those numbers to find the difference, but you have to take it from both sides. So in this case, if we want to do 4 equals, 4 has the 5 on the same side of it. So if we want to equal it, we have to isolate the variable by getting rid of that 5. So all we do is subtract 5. And if we do it on this side of the equation, we also have to do it on this side of the equation. So 4 plus 5 subtract 5 is just 4. And then 9 subtract 5 is 4. So 4 equals 4. We know. It works. All right. So we have a fact family here. This is taking all the numbers in that equation and rearranging them in different ways to check our work. So 4 plus 5 equals 9. But using addition, remember we can do it in any order. So 5 plus 4 also equals 9. Then to check our work, we can do 9 minus 5 equals 4, and 9 minus 4 equals 5. Easy peasy. All right. So now we're going to look at rearranging the numbers in this addition fact to form another addition fact and 2 subtraction facts. We practice doing this just to get used to doing things in a different order, mostly because it doesn't matter. So it's good to just practice doing it in different ways to see that it doesn't matter. So we can form another addition fact by reversing the addends. So instead of 11 plus 14, we could also write it as 14 plus 11. And then for our subtraction problems, we can take the difference, or the sum, and we can subtract one of the addends. So 25 minus 14 equals 11, and 25 minus 11 equals 14. So that's just 2 different ways to write the same problem. Rearrange the numbers in this subtraction to form another subtraction fact. So 11 minus 6 equals what? 5. So we can solve for it first, then we know the answer, so we can do 11 minus 5 and know that that equals 6. So that's another way to write it. 11 minus 5 equals 6. Then for our addition facts, we just take those sum numbers. 5 plus 6 equals 11, and 6 plus 5 equals 11. Again, it doesn't matter the order. That's it for today. We covered a lot, so you'll need to work through your problems to make sure you understand these concepts. If you don't understand the concepts, talk to your teacher about it or write a comment in the comment section of the video, and we'll give you some pointers on how to figure this all out. All right, it's been nice being with you for lesson number 1. I'll see you next time for lesson number 2. Bye-bye.